recording officially. I'm really excited to start off our April, which is our Undiagnosed month. So hopefully this lecture and then the one by Dr. Votto in 2 weeks you're going to find really helpful. As always, I'll be recording these chats that we have, and I will send you the link, and they'll also be uploaded to the web portal for your access throughout the year. So Dr. Gahl is here with me. We're sitting in his office on the 10th floor of the Clinical Center at Bethesda Medical and NIH. And just so everyone knows, it is finally a pretty day here in the DC area. It has not been pretty for a while, and the clouds are amazing and one of the best views in the city. So I'm going to be sitting here, and we quickly learned, Dr. Gahl and I, that it's more fun if we just kind of make this a conversation. So I have my computer open in front of me, so if you have a question you want me to ask, type it to me anytime, or we'll have a little bit of time for questions at the end as well, or you can always text me your questions. Now, if you're listening to this recording and you missed out on the questions, guess what? I will hunt him down and ask him your question and reply with it. So at any point, let me know if you have a question for Dr. Gahl, but we're going to start. And as always, Dr. Gahl, will you just tell us a little bit about why did you even get involved in rare diseases? What in the world were you thinking?
Well, my background is in biochemistry, and I love biochemistry. And I realize that biochemistry has applications to pretty much most of the human diseases. And I recognized that early when I was in college. I took all the biochemistry I could. I planned to be a biochemical geneticist and a person who studies inborn errors of metabolism. Actually, I took a course in college that was offered at Harvard Medical School by John Stanbury. And I worked in John Stanbury's lab, and he wrote the first edition of Metabolic Base of Inherited Disease. So it was an early interest in inborn errors of metabolism, and then I sort of segued into genetics from that and studied a lot of rare diseases, even some that weren't classically biochemical diseases. Of course, most biochemical geneticists believe that every genetic disease is a biochemical disease, and it's just a matter of time before the world recognizes that.
That's true. They just don't know it yet, right?
Right.
Right. So we have a lot of people on our call that, you know, they have been told that only geneticists or biochemical people do rare disease, and yet they find themselves in the rare disease world, maybe as a nephrologist or adult pulmonary doctor. Can you tell them a little bit about kind of when you started that there probably weren't that many people doing rare disease research? How do they kind of work their way into a field where maybe it's not that well established in their kind of category of medicine?
Yeah, well, fortunately, nowadays, we do have exome sequencing and genome sequencing and next-generation sequencing that reveals a lot of the rare disorders based upon the genes themselves and the variants in the genes. So really, a lot of the specialties, especially cardiology, and for somatic mutations, cancer, and as you said, nephrology, and even a lot of bone diseases, now have such a genetic basis, and you can discover the rare disorders among those, let's say, classical phenotypes. And so that really brings a lot of more people into the rare disease arena. Probably it's the genetics. Before that, it was people's interest. In other words, you could have a dysmorphologist who was really interested in bones or dysplasias. David Reemployed would be an example of that. And so he studied a lot of rare skeletal dysplasias as well as some common ones. But you can enter it either through the phenotype, I guess, because you want to be the world's expert or the country's expert, or you can enter it through the genomics, where patients who have some unknown disorder are found to have a variant in a certain gene, and then that piques your interest.
Mm-hmm. Yeah. Can you tell me a little bit about how you kind of, when you started your journey in rare diseases, why did you decide to stay in rare disease instead of going into something more common? How did you kind of find a niche in the rare side of research?
Well, the rare diseases, first of all, they're very suitable for a pediatrician because a lot of them manifest early in life. So that was really a pull. But besides that, the rare diseases require some research at the bench. Now it's actually at the computer, too. But it's really at the bench at that time. And the discovery of mechanisms, which has always been a real interest of mine and part of my early training, was basically when I was in college at MIT, we only did problem sets. So there was some reading, but most of it was a problem set every week for every course. So in other words, it's solving problems. And rare diseases provides you with the opportunity to try to solve a mechanistic problem for this rare disease or for that one, because the mechanisms aren't all known. You know, the phenotype may be known. Sometimes even the molecular basis is known, but that doesn't tell you the pathogenesis or the etiology or the mechanism. So that is really what appealed to me. And that's why when I came to the NIH, I studied a rare disease called cystinosis and worked on developing what was the basic defect or the mechanism of that disorder.
Mm-hmm. So in all honesty, you're known in metabolism, at least, as being someone who's gone from identifying the basic kind of underlying mechanism of disorder all the way to treatment. You want to talk to us a little bit about how you got through that whole pathway as a person?
Well, I came to the NIH in 1981, and I worked in the laboratory of Joe Schulman. And a lot of people had studied cystinosis prior to that. And at the time, it was known that cystine, the disulfide of cysteine, the amino acid, the cystine was stored inside lysosomes. And people didn't know why it was stored inside lysosomes. So there were some theories. There could be, for example, an enzyme that was missing, and maybe the enzyme's function was to break the disulfide bond of cysteine. But those enzymes had been looked at, and they were not found to be abnormal. So another possibility was that cysteine couldn't be transported out. So my project was to try to determine the transport characteristics of cysteine and see if they were defective in cystinosis cells. And I can sort of tell you how we did that if someone were interested. But that was the first element of this. And essentially for the NIH, if you want to get a job, you have to do the basic research. That is to say, it's really, especially at that time, maybe a little better now, but not a whole hell of a lot better. But at that time, you were never going to get a job here by taking care of patients.
Yeah.
So that actually, finding the basic defect in cystinosis as the first lysosomal transport defect, and proving that was something that made people want to keep me. So then, once you actually get a job here, you can use the clinical center to do clinical research. So if that's your first love, for example, you can see a lot of patients, especially rare disease patients, because the clinical center has an infrastructure to care for those individuals and do investigations, and it has enough money to pay for their travel. And so pick the right disease, and you can become an expert. So I did. And I saw probably in the course of 3 or 4 years about 150 patients, which was many more than anyone else in the world had seen at that time as an individual. So that allowed for doing interventional studies. And it wasn't actually my idea to treat these individuals with cysteamine. It was actually Jerry Schneider and Jess Taney's. They were at San Diego. Jerry was the principal investigator, and Jess, at the time, was his postdoctoral fellow. And they came up with cysteamine because they demonstrated that it depleted fibroblasts from cystinosis patients of their cystine. So then there was a clinical trial. But one thing that the NIH allowed us to do here was to see the patients every 3 months under a very stringent, rigid protocol so that we collected all the data in a pretty complete way. And that actually provided the basis for a paper. There was actually 2 papers that were published in the New England Journal and a subsequent submission to the Food and Drug Administration for approval in 1994, which was basically, 23 years, no, 13 years after I first came to the NIH. I'm dating myself.
That's okay.
Yep.
So you mentioned several times that part of the reason that you were successful was because of the resources here at NIH and some of the clinical center and some of those resources. What about all the people on this call that maybe don't have access to NIH?
Well, you can get some things at other centers. Mm-hmm. For example, there are the CTSAs, which are clinical research centers that allow for research beds at hospitals. And these are major medical centers, of course. There's 60, 65 of them around the country. Mm-hmm. So most of you, I would guess, are at a medical center that involves something like that. So that's, one way to get access. Another way is within your department, if you can set up a specialty clinic that makes you the expert by seeing a lot of patients. If it's a rare enough disease, then physicians around the country will want to refer to the expert. And you can make yourself that expert by essentially putting out a shingle, telling the Society for Inherited Metabolic Disorders that now you're recruiting to see patients with such and such a disorder. And if there's no competition, and often there is no competition in these rare diseases, you can be the person that people send their patients to. Now, there's some issues with that. I mean, one issue is travel. So if the disease involves really, really sick people, they may not be able to travel, especially kids. And there may not be money for travel. But you might be able to get money from your institution because third-party payment will make money for that institution. And you might be able to get money from an advocacy group or a philanthropist. If you can tell your stories of this disease, and particularly a child with that disease, in the newspaper or on the local television or things of that sort, that can bring in enough money to travel some of the patients, and you can make a name for yourself by being sort of the expert in that.
Well, and one thing we've also talked about with some of the family groups is that if you're willing to kind of be the advocate for that disorder, identifying a family group, and as we've talked about before, hit the NORD website if you don't know if your disorder has a family group. That's an easy place to start. But that's another resource that maybe they can't come to you because they're fragile, but maybe you could go to them at a family meeting too. Have you worked with family groups, and what's been your experience with that?
Well, I've worked with a lot of family groups, and I guess in a way the experience is mixed. In other words, I wouldn't say it isn't really 100% spectacular, but some of the family groups are spectacular. So, for example, the Hermansky-Pudlak syndrome family group has a founder named Donna Appel, and she's incredibly eloquent. She dined with Clinton's vice president, which is Al Gore, a couple times, and she gives talks to medical students and stuff, and so she's really spectacular. And there are, for example, there are 3 cystinosis advocacy groups, which is sort of ridiculous. But the point is that sometimes there are advocacy groups where there are secondary gains, let's say, for some of the leaders of the advocacy groups. Mm-hmm. But advocacy groups are absolutely invaluable for recruitment, sometimes for some money and for grants and things of that sort, but mainly for recruitment and for an understanding of the disease and what is needed. So the patients, families will tell you themselves what's most important in their lives. And finally, when it comes time for a new drug application to the FDA, the family groups have a say there with the FDA, and what they say, the FDA is now beginning to listen to a little bit. Yeah. Let me mention a couple of other resources, too. One is the Office of Rare Disease Research, which is now within NCATS, an institute at the NIH. And the Office of Rare Disease Research has a long history of providing relatively small amounts of money for a workshop. So that if you are like, I was going to say a young buck, but really, what's a woman buck?
No. But I think we probably shouldn't say it on a recording. A young investigator.
Yes, there you go.
Investigator, there you go.
So let's say an aggressive investigator.
Yes.
You know, like the JCI would call them Young Turks, for example.
That's right. Yes.
So someone who really wants to be the leader in the field of a rare disease that is relatively neglected, you can apply for some money from the Office of Rare Disease Research to have a workshop. And you, as the principal investigator of that grant, which is generally about $20,000 or so, and requires about a $5,000 input from your own university or from an advocacy group or something like that. If you can put together that workshop, you can decide whom you're going to invite, and you can write about it afterwards. And that's a workshop that can set policy and can, write a publication that will be what's referred to in that disease to sort of set the agenda for the future. And that gives you a huge amount of credibility, including, possibly your next grant, whether it's from a university or from the NIH.
Right. And that would count as a funded grant, too, if you're working towards grant funding. So
that's true. You get credit for it.
Yeah. So we're going to transition your comments a little bit now. And I want to hear...
Just because of what I said?
No. That's okay. I want to hear a little bit about why did you decide to even start an Undiagnosed program, and kind of what were your thoughts going into it, and what did you expect? And we'll talk about where it's ended up.
Well, for one thing, because of my interest in mechanisms and in discovery of new diseases, I've always had an interest and almost maybe a passion for studying undiagnosed diseases and discovering the cause. In fact, just incidentally, at my Board of Scientific Counselors review in 1989, I suggested that my laboratory would study undiagnosed diseases that had no known pathogenesis. And it was completely shot down by the board. and actually the reason was...
Even though it was shut down, you didn't give up? Go you.
Well, so I kept the thought in the back of my mind. But the reason they shot it down was because it's not right for everybody at everybody's stage of career, for example. That is, people advance in our environment in biomedical research by becoming an expert in something and writing the papers and doing the reviews and getting grants. And you don't get grants, by and large, for being a jack of all trades who's good at a lot of different things. So their advice was probably accurate for me at that age, which is, what, 39, so something like that. So I understood that was right. And actually, if I started an undiagnosed disease program at that age, not only wouldn't it have allowed me to advance enough to have the influence that I have, but I didn't have the knowledge. Yeah. I didn't have the friends, the connections. So there's a time for everything. The time was 2007, and around 2007 and 2008, a couple of things happened. First of all, the NIH as a whole wasn't real happy with the amount of use that the clinical center hospital was having. They wanted to enhance the occupancy and the use of the clinical center. So they had a bunch of committees. The institute directors did. And there was one institute director and a scientific director, which is the head of the intramural program for that institute, be the head of this committee and that committee and blah, blah. So they came up with a few long-term goals and a few short-term goals. And one of the short-term goals was to establish what they called fascinoma clinics. And they don't use that word anymore because it's maybe a little bit derogatory or pejorative, but the institute directors at the time had grown up seeing unusual cases and studying them for their mechanism, and they did that in largely the 60s and 70s. So they were sort of thinking back how important that was. So there was an institute director and a scientific director that had this committee to study how can we establish more fascinoma clinics. So, but at the same time, there was an Office of Rare Disease Research that was getting calls, it was supposed to be calls from rare disease patients, but a large percentage, or relatively 6% of those calls were from patients who didn't have a diagnosis, and the patients who did have a diagnosis took, on average, like years, like 5 years or so to come to a diagnosis. So the Office of Rare Disease Research perceived a need to study undiagnosed patients. And I was close to the head of the Office of Rare Diseases at that time, Steve Groff. So that was one aspect. The other aspect was I got myself put on that NIH committee to study fascinomas. And I told them that I already had $280,000 from the Office of Rare Diseases to hire 3 people to establish a sort of clinic or a program called the Undiagnosed Diseases Program. So then that committee of NIH director and scientific director and a few other people, they said, okay, we won't do anything, see how your thing goes.
So you give it your try with your money.
Yeah, so they did that. So then it was announced on May 19th, 2008, making this the 10th anniversary. Mm-hmm. And when it was announced by the director at the time, Elias Zerhouni, and there were like 90 advocacy groups on the phone or in the room, and about 25 journalists or TV people or so. And then it got so much publicity that we were sort of overwhelmed. But that was the genesis of that.
You had 3 employees to be overwhelmed.
I had 2 nurse practitioners I hired, and then a scheduler. And they were on board within probably a month or so. But then these records came in. And so remember, I'm a pediatrician and a biochemical geneticist. And the records were coming in from adults who had all sorts of things like that I didn't hear of, I hadn't heard of, I mean. So it was actually very scary. I sat right here at this desk, and I started opening these things up, and I said exactly the same thing that my son said once. My son went to the Naval Academy, and on the first day at the Naval Academy, we went out there to drop him off. It was July 1st, and we dropped him off early in the morning, like 8 o'clock, and we got to see him for 3 minutes at 5:30, and he came back with his head shaved and his uniform on, and he says, "Dad, not sure what I got myself into here." And those are my exact words at this desk.
Yeah, when the boxes of files started coming.
Oh, yeah, it was. Yeah, I was really afraid of the responsibility.
Yeah,
because I didn't know exactly what I was doing.
Yeah, yeah.
But again, you know, there's a lesson there too. You have to be willing to fail. And, you know, we fail a huge amount. But if you're not willing to fail, you're not going to try to be the expert in a rare disease or to establish an undiagnosed diseases program. You know, you have to be okay with that.
Yeah. Just willing to take those risks.
Yep.
Yeah. So tell us a little bit about kind of what's happened since you got your first box.
Well, there were many, many steps along the way about how one would conduct a program that had no precedent.
Right.
You know? So, and actually, it was really advantageous to have nobody else in charge. You can make all the decisions. And I noticed the difference now when we have an undiagnosed disease network that covers the country. You can't make any decisions anymore. It's got to go through a committee and stuff, and 3 committees and stuff. Anyway, so we tried to establish some sort of principles or procedures. And the first thing we did was try to refer patients to existing NIH intramural clinics. So people who were expert in such and such, we'd send the chart there, say, you interested, et cetera. And for about 4 months or so, these clinics picked up a bunch of patients, like probably 30 of that order or so.
Yeah.
And then they stopped pretty much completely because they found out that these patients were really complicated, and it diverted them from their main interest and from their professional advancement, frankly, because these were, tough cases, and it didn't make them more expert in their field. It distracted them from that. So then we had to start to take all the patients ourselves, and didn't have enough money for it, so sort of getting the funding became the issue. And Elliot Zerhouni helped us out a lot. In the first year after that, which was 2009. No, it was 8. He got us $1.9 million.
Wow, that's a lot of money.
Yeah, well, it was at that time, yeah.
For a new program, yeah.
Actually, that was 2009. And then he left, and a month before he left, he set aside $3.5 million a year for fiscal years 10 through 12 for this program. And that allowed us to do all sorts of things, including expand our clinical enterprise, hire nurse practitioners, hire a neurologist, an internist, and then half-time people here, and then people in the laboratory, and set out contracts for functional studies, and basically do research on some of the variants that we found, and support the next-generation sequencing. The exomes are just coming into the fore, et cetera. And that money ran out in 2012, and then we asked the directors of the institutes for support, and they thought that we should apply to the Common Fund of the NIH for money after that, and we did, and that was a lot of money.
Yeah.
So tell them about the Common Fund?
If you want to, up to you.
Well, briefly, the Common Fund is $650 million a year that's given by Congress, and it can't be used for anything except innovative programs that are across the NIH and involve many more than one institutes.
Yeah.
And so they have about 25 of those programs. It's about $20 million a year, and they can only last between 5 and 10 years. So our program was approved for actually 7 years, but after 5 years, it went through its second iteration, and now is approved for a second 5 years. So this program is over in 2023. The last funding is 2022. But it is for about $20 to $25 million a year, divided among 7 clinical sites with 2 sequencing centers and a coordinating center, a model organisms core, a repository core, and a metabolomics core.
So would it be fair to say it's expanded a bit since you started?
Well, I think between 280,000 and 140 million is 500-fold.
Yeah, yeah. So we've all probably read some of the publications that have come out about the work that you've done. Do you want to tell us just a quick story of maybe something we haven't read about, or a case that you find dear to your heart?
Well, we're actually about to submit a paper about someone who has a gain of function in a gene that pumps chloride into the lysosome. And because it...
You're back to the lysosome.
I am.
Yeah.
And because it pumps chloride in, it causes the lysosome to be too acidic, hyperacidic. And while all of us think about lysosomes as, let's say, not being acidic enough, not having the proton pump, or not having the enzymes functional because they're missing or there's an acid problem. In this case, because lysosomal enzymes have an optimal pH with less activity on each side of that pH optimum, when you have hyperacidity, you also have decreased enzyme activity. So the manifestation of this disease is lysosomal storage. The big liver, big kidneys, and hypopigmentation too, because the melanosomes in melanocytes, which are lysosome-like cells, and the melanosomes are like organelles, they don't have the proper pH either, so they don't make melanin properly. So point is, it's a new disease, and really exciting, and we're submitting it. We're supposed to submit it last Monday. Well, long story.
I know, and as I'm sitting here, I'm like, oh, I need to find more about this, because I think I have 2 kids that you're describing to me that I see and I cannot find a diagnosis.
I'll show you right away.
So we'll look at this after we hang up on the phone, no worries. But anyone on the phone who has a question you want to talk to Dr. Gahl about? I'll ask one while we're waiting for questions. How do you balance this crazy life here at NIH with having any other personal life, or, you know, everyone's always asking about work-life balance. You want to tell us a second about that?
Well, first of all, if you have a significant other, it should pretty much establish that, because that's a big help. You got to have some, you know, reasonable life at home, and not bring your home problems to work, or vice versa, I guess. So, you know, that's important, and my wife has always supported me enormously, so that's been helpful. I think, too, that at some point in your life, when you have children, for example, you have to give that priority. And so I spent a lot of time with my kids at that time. Now, in my twilight years, I'm not spending so much time with that, maybe some time with my grandchildren. And then I think you have to have some avocation as well, or at least I recommend it. So my avocation is I play softball. I play a lot of softball, probably 80, 100 games a year, travel around the country, etc. And I'll tell you, there's another advantage to that, and that is you're playing with regular people. I don't think that those of us on the phone are like really regular people in a way. And you know what I mean by regular. I mean,
we know what you mean.
People who have trouble with you know, things like money and you know, their own illnesses and stuff like that. People who curse, for example, those are regular people. So the point is that this allows for some balance in a rather intense life.
Yeah, yeah. Remember that not everyone lives this life.
No, it's
all there is.
It's true. In a way, it reminds me a little bit about being a pediatrician or being a nurse in a neonatal ICU, or being a hem-onc doctor or nurse and watching children die. And that takes a certain person. You could take, if you're too much of a bleeding heart, you can do it superbly for a while, but you can't do that all your life by and large. The same thing for the military. You can't be in the military unless you can endure someone hollering at you for a while and say, screw that. You know, you have to be able to let things bounce off you. Yeah. And so, you know, special people in rare diseases. But those special people also get a special satisfaction from doing the work that they do and from the patients they care for.
Yeah. Yeah. Anyone else have a question for Dr. Gahl? Oh, they're being shy today with you.
Okay, well,
that's okay. You guys are allowed to be shy if you want to be.
Thinking of, you know.
I'm the lucky one.
What the.
I do whatever I want.
Yeah.
This is great.
Thinking of what the mushrooms said, you know.
Oh, no.
Why won't you, talk with me? I'm a fun guy.
Oh, we knew that was going to happen. Thank you for choosing that joke, though.
It could have been worse.
If you come in person, you can hear much worse jokes that he's not allowed to give because we're recording. So
that's
he knows
true.
That. Is that fair?
And after all, I'm a government employee, and you know how,
you know how that goes.
Ethical the government is.
Yes, we do. That's okay. This is through Children's National, which is not a government employee. I am not one, so it's okay. Anyone else have questions before we close for today? Well, Dr. Gahl, so I don't know if all of you guys know this. I should probably disclose that he was one of my mentors, and I can tell you this man does an amazing job taking care of patients and families, and they adore him. So thank you for sharing your story with us today. I really appreciate your time. Thank you.
Thank you, and you can actually email me if you have any issues that you think I can help you with.
Yep, and I can get his email to you if you guys ever need it. Feel free. He's a great guy, and it's also good to know that someone at NIH is doing this work. And don't forget, if you guys have patients and you're in a conundrum, you could consider the UDN as a submission. I'll be honest, I've submitted 3 or 4 kids, and they've gotten some really great care, and they were able to do genomes when I couldn't, and it's fun to be able to offer that to a family. So remember this resource and use it. If you need help with a UDN submission, feel free to reach out to me, and I'll help get you the contact information if you ever need it. You should really do that.
Yeah, and I will too. You can email me about a case. Happy to discuss it.
Yeah. Great. Thanks, everyone. Have a great afternoon. Take care.